Hello, everyone. So, in this session, we are going to practically implement adaptive thresholding. In the last lecture, you have seen that how we implemented simple thresholding, and there we used one global value as a threshold. But in some images where different lighting conditions are there in different areas of that image, that single value or that common global value as a threshold is not going to work. Okay, so in such cases, we need to take the help of adaptive thresholding. So where we will use this adaptive thresholding, first question. So the answer will be in images where you will see different lighting, means from the image itself, it will be very clear that that is kind of image with different lighting variations. So there we have to use this adaptive thresholding for better thresholded image result. This algorithm, this adaptive thresholding algorithm determines the threshold for a pixel based on a small region around it. So we get different thresholds for different regions of the same image, which gives better results for images with varying illumination. So you have seen that consider a pixel and a small region around it. For that particular area, for that particular region, there will be a specific threshold value. Then for a pixel in a different region, there may be a different threshold value. So ultimately what will happen, we'll get a good result, or you can say better result, right? In such images where varying illuminations is there. Now, is in last class, I have explained about this CB threshold method. Now, addition to that, we have to know about other parameters that is going to be used. So the adaptive method decides how the threshold value is calculated. First, this value, CB adaptive trace mean C. The threshold value is the mean of the neighborhood area minus the constant C. About C, you have seen that we discussed about that already. Okay, don't miss the last class, right? You will find the link then in this series itself, you will see, or in the end of this video, you will see the link. You just click and watch the last lecture. Okay, you got it. CB adaptive trace mean C. Then CB adaptive trace Gaussian C. So this threshold value is a Gaussian weighted sum of the neighborhood values minus the constant C. That is the difference. The block size determines the size of the neighborhood area, and C is a constant that is subtracted from the mean or weighted sum of the neighborhood pixels. Okay, now this code that we have implemented, I already implemented, I'll show you. So this code actually gives you one more thing, that it will also compare the global thresholding and adaptive thresholding for the same sort of image. So you will see the result where the result is, you can say the output image is better after the thresholding. So import CB2 as a CB from matplotlib, import pyplot as plot. So these two, import CB2 for OpenCV, we are importing as CB. Then from matplotlib, what we are importing? Pyplot. Okay, this is the location of our image in the D drive. But here I have put this parameter, that is CV imread grayscale. So that image will be converted into the grayscale version. This is the message if image not found. Then we found this, that is the median blur image, this single image that they are input image, comma 5. So with that, we have calculated the median blur. Then CV threshold image, this current image 127, 255. You know the min max value, last class I've discussed. Then CB trace binary. There's a binary, that is the single, or you can say the common thresholding we discuss. Right. So common thresholding is done with this CB trace binary. Well, that value will be stored here. Then thresholded 2 version, CV adapted thresholding, image 255, then CV adapted trace mean C. Okay. Then CB trace binary 11. Then see, this next one is the Gaussian version of it. Same thing, CV adaptive threshold, but that only since the parameter is this one, CV adaptive trace Gaussian C. Others are same. Okay. Then titles, original, global thresholding. First, V value we have capped as 127. Then adaptive mean thresholding, adaptive Gaussian thresholding. So single plot, we are showing all the images from the original images to the thresholded version 1, that is the common thresholding, or we can say global thresholding, then this adaptive thresholding, and then with the Gaussian version of it. Now, how many parameters? 4 parameters are there. So single for loop for I in range, subplot it 2 cross 2, that is I have a 2, 2, I plus 1, plot image show, images I, gray, then plot title, titles I, plot X ticks, plot Y ticks, then plot show. So all the images will be shown in a single plot. Well, I think that this code is clear to you. Now let's implement this. So I'm opening my Spider. So you can see here the code that I have just discussed. Now let's run this. So you see here, this is the original image, right? This is the global thresholding. What value we have considered? Value 127. So this is the global thresholding. Now, this is the adaptive thresholding, and this is the adaptive Gaussian thresholding. So you can clearly see this is the global thresholding because of the lighting variation. So thresholded image is not so clear. Clear in the sense for your purpose. Why we do the thresholding? We have obviously we need to find out the different objects, or you can say in this image, if you look at the original image, so this and these are the hairs and these are some artificial. But what happened that in the thresholded image they look same, so no big difference. But in this image you can see the clearly the difference is there. So similarly the other parts also clearly thresholded so that we can detect the different objects there. So in the case of adaptive mean thresholding, even in the adaptive Gaussian thresholding, you will find the results better than the global thresholding. So in this class, we have compared this global thresholding with adaptive thresholding also. Well, if you have any doubt, then please ask me, use the comment section. I will meet in the next lecture. Till then, take care. Bye-bye. Don't skip the practical. Okay, bye-bye.